Okay, hello everyone. Welcome to the wasmCloud community meeting for Wednesday, May 15th. We're going to be doing a really fun thing for today's meeting where the way that we've laid out this agenda, we're actually going to do everything backwards. We just want to make sure that we're keeping everybody on their toes and keeping you prepared so that, the agenda we could be doing anything, we could be going in the reverse order. It's all fun stuff. So while we get the demos and discussion queued up, I just want to do kind of our regular roadmap check-in. We won't necessarily, I'm completely open to doing this the way that folks prepare or are prefer to work here. I do really like checking in on the roadmap on a regular basis just to make sure we know what work streams are in progress and how we're doing. Though I don't want it to be a chore part of the community meeting, so happy to take some feedback there. So scrolling down to the bottom here, we have had some significant movement already with the wasmCloud roadmap. So we have fixed a bug, which can also be viewed as a feature enhancement for more restricted systems in terms of CPU and memory. So and when I say we, thank you so much to Taylor for really diving deep into this, but running wasmCloud on more memory restricted hosts will now use the wasmtime dynamic pooling allocator, which all this really means is the way that we're allocating memory for components. We're going to use a different strategy on smaller systems, which makes sense. We don't have as much of a pool of memory to pull from. So that should work really well. And that's included in the latest version of Wash. So just updating there, you should be able to run on, smaller VMs, smaller IoT, things like that. And I talked about it a little bit at the end of the community call. I believe it was last week, but we had significant improvements in terms of one button releases for our crates that depend on other crates in the wasmCloud monorepo. So it's really nice to actually get that kind of wrapped up. And now for Wash 0.28, we actually almost entirely use that process to release that. So we're just going to keep improving on that. That's something more on the maintainer side, but it's still exciting nonetheless to deliver artifacts a little quicker. So you may have seen, nice job, whoever is updating their sprint task in the meeting. We did release wasmCloud Lattice Client as an NPM package. Lachlan put up a PR for that last week and that merged. So for anyone who's working in the JavaScript ecosystem looking to interact with wasmCloud ecosystem things, you can see example usage of that client in the wasmCloud dashboard or the washboard directory in the monorepo. And this is the UI that you get when you run wash UI. It's a really impressive set of improvements there. So hats off to Lachlan for that. So already getting some stuff knocked out, which is great. For as far as in progress work, we have some RFCs and some documentation that are moving across the line. The WebAssembly working group in the CNCF and the runtime tag published their recommendations for publishing WebAssembly artifacts in OCI. So, like the other things in the wasmCloud world, we're of course going to adhere to as many common standards as possible, and Taylor is working on adding support to our tools to use that new artifact type. There's nothing really to do here. We're still interacting with OCI. So at some point in an upcoming wash release is a new minor release. We're just going to add support for pushing with that new artifact and manifest structure. And of course, the support will be added in wasmCloud at that time as well. So more to come there and more to come around the wasmCloud Postgres interface and implementation. But these are going to be things that I think we'll be asking in the community Slack over the next week or so for additional feedback and testing. And then we can bring them up in the other community calls. I know Victor is spearheading the work here on the Postgres interface, and Bailey wrote the original RFC, so it's really really exciting to see that move across. Other than that, I don't think that there's really anything else to see here under triage and ready for work. These are things that we haven't done yet. But if you haven't seen the actual roadmap and how we came up with it, you're welcome to go to the wasmCloud documentation. Down here on the roadmap page, we have updated this to the 2024 Q2 roadmap, and it includes our goals, high-level features, and the community meeting where we brainstorm this with everyone. So really, really cool to see this move across. So I think next week and weeks going forward, we'll just touch on tasks that change status in the roadmap and potentially do some call outs for good first issues for people in the community who are looking to contribute. All right. Do folks have any other questions on the wasmCloud roadmap or what's moved so far? Nice. Okay, then I think what we can do is continue up our little inverted chain. Roman, I think that you wanted to demo some progress and talk about the progress with WRPC in Go. Would you, well, don't need to ask. I'll go ahead and hand it over to you.
Thank you. So I'm hoping you see my screen now, and it's hopefully it's big enough for everyone. Right. So, well, two things. So first, you might remember, I guess 2 weeks now ago, we had Hackathon, and I, tried just see how hard it would be to make something like a Go provider for the outgoing HTTP. And so you might remember also that for the provider, well, with our PC, HTTP contracts, which I can actually show. We use actually two features of preview tree in WASI, which is streams and futures. Where like the body of your HTTP request or response is streams rather than being sent a big chunk of bytes, right? And similarly for trailers, this is something that well, may arrive or may not arrive, right? In the end, after the whole body has streamed, right? This, let's say your, and website, it may return trailers in the end, right? And so these are two features that we have in WebAssembly, which is fully supported. And so I'm actually pretty happy to announce that I have just implemented, went quite a long way from that little hackathon demo to actually have full support for this in Go with Bindgen with our PC, meaning that you can now write interfaces using streams and futures, and with Bindgen with our PC is going to be able to actually correctly handle that and generate bindings for it directly for you. This first, so basically the way it works again is I can do Go generate, which actually just runs Bindgen with a PC. Go, we've seen it before, but just for example, that's what it does, right? It's just runs with Bindgen with the PC now and sets the path to it and a package which to generate bindings. And that's it. And so now what I can do, I can try to run the server. This will actually work. I can try to run the client. And this will just send requests to google.com, and you see here it's, present status code and headers and the Google web page. And let me show you the actual code. That's the wrong place. The one. What Bindgen WC actually generated for us was the one. Right. There we go. So there is a serve function which we can use to serve our world, which we are exporting right here. So you can see here I have a world server, and so server exports the WC outgoing handler interface, which is defined in my dependencies right here, here, and it has exactly one function, which is handle. And so I do have a handler struct I have created here, which has handle method implemented on it. And handle, just like the root contract, takes a request in, it takes the optional request options in, returns a result. Or maybe I'll just close this one. There's a result of a response or an error code. right? So then, well, you can parse this and use functionality all generated by with byte WebAssembly for me, right? And just send a real HTTP request with Go. And so one thing that was also a big chunk of work this week I've done and last week is the actually client binding generation for it as well, where now I have an actual the same handle function that you see in the server. Now you can also invoke it from a Go client using the same, well, almost the same signature as the server one. So it just takes the context of the first parameter, it takes WebRPC client, the second parameter, and then it just takes all the same parameters you see in the with contact definition, right? And then all I can do then is I can just call this function. I check if it's an error or it's success, and then I can just print the headers as you've seen before in the CLI, right? I can read the whole body, I print that to the CLI, and just stop the whole communication. So yeah, that's my demo. Pretty short. I hope it was clear. Any questions about this? What we just seen?
I'll continue to
So,
do my pretty classic. Oh, sorry, Colin, I didn't see you.
oh no,
Go
no,
ahead.
Dan asked a really good question. I was gonna ask a lesser version of that question, but I think Dan's question's a good one.
Okay, yeah, I'll go really quick because I was just gonna so now Roman, this is what we showed last week. What we showed last week, right, was being able to generate WRPC types in Go and then turn that into a capability provider. And so this demo kind of showcased taking that a step further with the futures and streams bindings generation and how to use that. That's is that right? So now like I could use the futures and streams using could I use it in Go bindgen and Rust bindgen as well?
So yeah, funny enough, Go bindgen is not actually way ahead of Rust bindgen. So yeah, you cannot do it in Rust yet. You can do it in Go. And the only thing left for Go support is resource support. I actually have it's like halfway done already. I was hoping to finish it today, but I think maybe this week it should be done. So as a matter of fact, this with RPC HTTP contract that I've showed, it actually imports WASI HTTP, which does use resources, because it in turn imports IO and poll and whatnot. And so the bindgen today is actually able to generate, well, some signature for resources. It's just it doesn't really it doesn't actually manage them for it yet, but it does actually generate all the necessary stuff to actually do it already. So it's able to generate bindings for the whole WASI suite of things, actually. Yeah.
Cool. Yeah, really cool. I know that for 1.0, like right when we started, we told folks not to, that we didn't have bindgen support for future streams and resources anyway. So that's really cool to see it. Like, yeah, that was all that I had. My question was more was around Rust, so it's fun to see that moving in different directions. Yeah, Dan or Colin, either of you want to take ownership of that other question?
Sure, I can rephrase my comment into a question and see if that actually is along the lines of what Colin was going to ask, which is, is there anything to look at in particular, like around an example of how to actually implement? In my case, I was looking at a pollable. I actually didn't realize you can't do futures in Rust right now, or a stream, just to be able to have a component actually, uh, if you have a wit, you actually write where there's a function that returns one of those types. Do we have any examples anywhere? Because I've looked at the wasmCloud host code, and I've even looked at wasmTime, and it's like wasmTime implements like their own type for pollables, and you get in the weeds really quickly. So I don't know if we have anything concrete there. If not, I may try and follow up um, after the call, because I'd love to have something in the open just to point at, even if it's super low level, because I'm trying to figure it out, and even I'm a little lost.
Right. Okay. So first, it depends if you want to. If you're talking about components, WebAssembly components, or we're talking
Component.
about with RPC, right? Yeah. So
Specifically a component I can leverage with RPC directly if I have to. but I'd prefer it just to be like I run with bindgen, I implement my function, and it just works.
Right. Yeah. So there's I think Joel's project
Yeah,
was
Joel had one.
yeah.
Okay.
So that thing has support for I haven't actually tried it yet, but it has support for async to runtimes, I believe. But for example, today's stable version of wasmType does not support either futures nor streams, right? And none of these actually are supported. Generally, it's all very experimental stuff, right? So it's just so happens that with RPC protocol does have support for these types, and we in fact use them already today in wasmCloud and HTTP over and Blob Store. But I believe so. I think outside with RPC context, let's say it's fairly, I think, still difficult to use these types.
Yeah, I think that was what I was getting at. I was like, you're showing. At first I was thinking it was WRPC. I'm like, okay, so it's like gRPC, and you definitely have streams in gRPC, and so like that's what you're doing. And then I saw it was in a WIT file, and then I started getting really, really confused because I was like, we don't have these yet. And I'm like, well, you have IO stream, and is that what you're using? Are you using WASI the IO stream in your WIT? And then I'm confused on like what exactly how you get streams into WIT files.
Right. So actually, streams and futures are supported by WIT parser. For like all the WIT tooling actually does support these types already.
IO streams. Yeah.
No, the actual native streams, the native futures. Like it's able to parse it. Like there's no tooling which will ever like general with bindgen wouldn't be able to generate bindings for you for either futures or streams. But these two types actually are fully supported by underlying technology libraries. And so what I actually showed is in fact native support for these futures and streams coming in preview 3. So they're not available yet in WASI. Essentially, it's something that is still experimental. Like
so you're saying it's defined in the WIT spec. It's not supported in WASI yet, but it's defined in the stream is defined in the WIT spec. Is that what you're saying?
I believe it's not even defined in the spec yet.
But I'm just saying you had a WIT file and you wrote stream in it. So how does that mean anything to anything that would ever parse a WIT file unless you wrote your own parser and then turned it into RPC?
Right. So WIT parser actually does support it. So WIT parser actually has a permission for streams and future types. Hey, Billy. Yeah. So like we have our own WIT bindgen, which for WIT RPC, which does generate those bindings that the upstream WIT bindgen wouldn't do.
Okay. All right.
Yeah.
All right. Because that is really confusing otherwise. Because
in the demo that Roman showed, oh no, Creeper Liam. In the demo that Roman showed, this was also from the perspective of the provider. I mean, specifically what Roman showed is the implementation of WidRPC in Go, and it's not a wasmCloud provider, but in the wasmCloud ecosystem, this would be on the provider side. So that's why, and since all of the provider bindings are now generated from WIT, that is the piece that is being shown here. So like the native IO and native streams is the native Go IO and streams.
I have more things to say.
Yeah.
Also,
go ahead, Bailey.
Thanks for the demo, Roman. It was awesome. And what he showed was in the context of WidRPC. If you want to see like the latest and greatest and get the download on exactly where we are in the Bytecode Alliance on supporting native async, and to be clear, we support async, but how do you do it, in a nice way that's composable? I hosted Joel Dice on the end of April stream on the Bytecode Alliance. We ran through all the news there, and basically the TLDR is ISO-SWAFA is practically deprecated now because Joel's amazing and he has already implemented most of this stuff inside WASM tools and with bindgen and all these other places. It's not quite rolled out yet, and yes, we're planning to roll it out with WASI.3. So okay, all right, I'm gonna slide out of Brooks's DMs here.
And okay, so Roman, that the width that you showed there, the stream U8, that's just in the you can specify that in width. The stream of U8 is a width native type.
Yeah, in fact, stream of any type, right? You can have a stream of future of anything, right? It's completely fully composable. And streams of U8 and futures of list of bytes, those two types are actually optimized in Go with BindGen. So it's going to use this native, IO reader, the Go functionality to actually do that, to avoid all the copying of stuff around other stuff.
Yeah. Okay. Awesome. All right. Do folks have other questions for Roman here on with RPC BindGen? All righty. Well, then I think we can go ahead and we're moving pretty well. We can move forward into oh, don't look. I was looking at WIT. The next section of the community meeting where I know that Dan and Jonas have been I know that Jonas especially has been contributing to the wasmCloud wasmCloud repo over the last week. If you keep an eye on the contributions, the PRs that go in, you may have seen the musings of releasing Wolfie images and signing those images. And this is something that I still have a lot to learn about. So thank you so much to both of you for coming on. I'll go ahead and turn it over to Jonas and yeah, go ahead, take it away.
Okay, cool. Thanks. So I guess I wasn't planning on touching on Wolfie too much, since it's not quite yet tagged or official, but maybe it's worth kind of talking to it just a little bit. For folks who are maybe not familiar with Wolfie, it's a container-based operating system, or a distributionless operating system, if you will. Sorry, not an operating system. It's a distribution of container, like an underlying file system that you can build, that's intended to be used for deploying essentially production hardened versions of software in containers. So the use case typically is that when you have a piece of software that can be statically compiled down to something, you would put it on as lean of a container image as possible to run it on a containerized system. So in our case specifically, where we would want to use this is if you're deploying a wasmCloud host inside of a Kubernetes cluster, and you don't want that host to have any CVEs being contributed to it from the underlying distribution that it's being layered on top of as a binary. Wolfie is a really good choice for kind of getting a zero CVEs out of the box distribution. And so we've chosen to begin building images as an alternative to the currently Debian-based distribution of wasmCloud on as an OCI artifact. So we began building an alternative that's based on Wolfie. That basically just means that we're getting the benefits that that ecosystem is getting from being sort of on top of all the security vulnerabilities and keeping their baseline very secure. So there's more work to be done there, and kind of a story to tell. But the upshot is when you're using the Wolfie-based images, you'll be guaranteed that you are basically getting zero CVEs in those images, which is nice. Typically, it's not that those things could easily be triggered through the host necessarily, but you might have some automation in your environment that's looking at the image and assessing the footprint that it might have. Like there might be a admission controller running inside of your Kubernetes cluster, for example, that might be checking the CV status of the image and see if it has any high, medium high, or critical vulnerabilities applied to it. And when you're building on something more general purpose, like a Debian image, those sometimes contain packages, those upstream images sometimes contain packages that are out of date, or they're just not very actively maintained. So this gives us a nice alternative to using the Debian image that's a more secure and more honestly designed for the kind of use case that we would be wanting to use for the wasmCloud host, because we don't need an actual operating system or even a shell for the wasmCloud host to run. We just need something that has certificates bundled in, and that's about it. And a static layer, binary layered on top. So that's the reason why we've kind of explored this space with in the Wolfie area. The other thing that I've been spending a little bit of cycles on, because of questions that have come up at conferences, but also from the community and just in conversations within Cosmonic, we've kind of been asking the question of like, well, what does the supply chain security space look like for WASM? And the good news is that WASM already by definition is quite a bit more secure than containers. So we have a lot fewer things to worry about than we do in the container land. But one of the areas that we've been, or I've been diving into, and some of the folks on the team have been diving into, is looking at what it might look like to be able to sign the WebAssembly components, modules or components that we're building. And I guess I can kind of share my screen here. Host disabled, participant screen sharing. You might have to promote me into a host because I dipped out earlier. Sorry.
Dang it. I did it before, I swear.
You did, but I had to reinstall Zoom, so
Nice.
let's see if it works. I'm going to play it dangerously here, and I will share my whole screen because I'll be popping in and out a little bit. Oh no, I actually have to grant it access now that I've reinstalled it. Sorry, I'm going to have to restart Zoom. I will pop back in. I'll be right back.
I'll
Sorry
have
about
the
that.
re-granting co-host ready.
Yeah, I'm sorry.
Yeah. Now is a perfect time for us to reconsider this policy of only allowed trusted parties can share.
Oh wait, did it actually? Can you see my screen now?
It
Yeah,
did.
it's up.
Yeah.
Does it
Guess
show
we don't.
you?
It
Oh,
lies.
wait.
It says you have to sign out and sign back in, but you don't. You just have to
Okay.
try again.
Yeah, I guess they maybe fixed that. Okay, so you can see my terminal right now. Is that what, right?
Yeah, I'd
Yep.
make the text size a little bigger, but yeah.
Okay. Okay. Cool. Okay, so the reason I've shared the entire screen is not because of these prompts, but it was because, so for anybody who's kind of hasn't spent time in this space yet, in the container side of the world, there's this project, really awesome project called SigStore that came out probably 5 years ago now, maybe less. But basically, they've been developing all this tooling for being able to easily sign and verify container images and other artifacts. Now, it turns out that because of where it started and how things have evolved, SigStore is now able to sign OCI artifacts in general, and that's great news for us because for wasmCloud and generally in the WASM space, when you're producing a WASM component and storing it in a registry, they're being stored as an OCI artifact. So the first question I wanted to answer is like, okay, given that we have SigStore already in existence and it works with containers, but it also works with OCI artifacts, how hard would it be for us to take a component that we've built in wasmCloud and just sign it? And so let's go in and do that. So I'm in my own checkout of just the upstream wasmCloud repository. What I'll do here is I will take the HTTP hello world and I will do wash build. Turns out I've already done that, so it's caching very fast. That's cool. So the next thing we want to do is actually push it into a registry, right? So let me take this handy dandy environment variable that basically just uses a repository called TTLSH. If you've not looked at TTLSH, it's an anonymous registry, basically. I think it's running Docker distribution behind the scenes that allows you to basically push artifacts into it, OCI artifacts into it, and give them a tag to tell it how long they should persist those artifacts for. So it's really useful for demos where you don't want to have to be signed into systems and like that. So what I'm telling it here is just give me a random URL for this OCI artifact that we're about to push here. So now that I have a URL generated, let me just do a wash push that URL and the built artifact. Right. Give that just a second. It should be getting built, cool, and pushed, sorry. Okay, so now it's pushed into the registry. And something new that Taylor added recently to the wash push command output is now when you're pushing an artifact into a registry, we show you the tag and also the associated digest that's related to that tag. So you can actually, this is the content addressable address for the tag, basically, or the blobs that are associated with the pushed artifact. Now, why do we need this? The reason why we need this, and I'll show you that in just a second here, is we're going to use a tool from the SigStore space called Cosign. So Cosign is this command line client for interacting with the entire SigStore ecosystem. And it is basically, the purpose of it is twofold. One, it's intended for signing artifacts, but two, it's also intended for verifying artifacts. So what I'll do here is I'll show you us taking this wasmCloud component that I just built, or the wasm component that we just built and pushed into the TTLSH, and actually signing that using Cosign. Cosign supports something called keyless signing, which means that you don't actually have to generate a key pair to sign these artifacts with. Instead, it'll prompt you to basically sign into one of their components called Fulcio, and that will, using OIDC, and that will basically take your identity and generate a certificate, a short-lived certificate that will then be used as part of the signing operation. So they basically do away with the need for certificate management for signing components by basically authenticating you against a system that they can verify that you're who you say you are. So let me just go ahead and take this. And the way it works is, instead of signing a tag, you actually have to sign a content addressable digest of the artifact. So you can't just say 1H in here, because that could change. The definition of that could change. Instead, you sign basically the version of the manifest that you just pushed. And so you basically have to give it this address. So the address of your artifact, and then the layer or the digest of the manifest that you're signing. And so here, if I run this, it gives me this very scary message about hey, are you sure you want to do this? It's public and all that. In our case, we'll just say, yes, I really want to do this. Because I'm doing the signing, the keyless signing process, it'll pop up this, the OIDC prompt in my case, and it'll tell me that, hey, I need to sign in, I need to identify as somebody, and this is the information that they'll then use to generate a certificate to validate that, to basically be able to say, you are who you say you are. So in this case, I will just sign in with, log in with GitHub. Then it'll redirect me back to my local machine, because it has a web server running in the background, listening for this callback. And now if we go in over here, what this output tells me is that basically is that we've now successfully created a transparency log entry for this artifact. So there's two services behind the scenes that Cosign is talking to. One of them is Fulcio, which is the short-lived certificate authority, basically, that issues a certificate for you based on your identity. And then once you have that certificate, it will talk to another service called Wrecker that is actually a timestamping authority that is used to validate that you actually signed this. You used the short-lived certificate within the time window that was granted for it. So within the 10 minutes. And now this basically says, hey, we've generated an entry in Wrecker for this particular artifact. And we've pushed that signature to the repository, same repository as an additional, attached piece of metadata to that manifest that I pushed earlier. Now, there's a couple of things we can do here. So one is we can use, they also have this handy dandy search.sigstore.dev website where you can search for things based on a bunch of different attributes that are attached to it. In my case, I'll use the log entry ID that they gave me as part of this part of the SigStore Cosign sign operation. And as you can see here, this was integrated a minute ago. It just basically proves that I did in fact sign the thing. And you'll note that it uses, because I'm using GitHub in this case, it'll pull my email address from GitHub and included in the certificate information, and as well as the OIDC sure that was used to verify that I am the person who I say I am. Now, you don't have to do this manually like this. You can also include this in build pipelines as part of GitHub, and GitHub has authentication for OIDC, has integrations for OIDC, so you can use OIDC automatically from GitHub to basically verify that the build was built by the specific pipeline. So this would be, instead of identifying me as a person, this would actually be related to the GitHub build pipeline. So it would have like which pipeline built this artifact and so on and so forth. Now, the second part of this is actually verifying that this thing is, or the artifact that I pushed is in fact the artifact, or rather was in fact pushed and is actually signed. So for that, I'm just going to copy paste some options here because it is a little bit verbose. So you have to pass in basically who is this thing signed by, and then what is the issuer of the OIDC that should be checked against. So saying like, this was signed by me using my email, and I authenticated against github.com/login/auth, which just matches one of the providers that are supported by Sigstore. Now, in this case, when I'm actually verifying the artifact, I can now use the tag instead of the digest. I could use the digest as well, but I'm going to use the tag in this case because it should be easier. And so I'm now going to tell cosign to go and actually check that this artifact that I just pushed at this address is now actually signed. And what the output here tells you, I'm actually not sure how to suppress this, but basically the output that you care about is basically this output that says, yes, the claim that was made did match, which means that it was signed. And there's also, that this information is available on the online transparency log. Oh, sorry, it was actually verified offline. I misread that. And then that there's the code signing certificate was verified using the trusted certificate authority. In this case, it's coming from Fulcio. So this is just to indicate that, yes, this artifact was in fact signed according to the public record. Now, that's all well and good. What is interesting also is that because we've now done this, what we can also do with this information is we can have wasmCloud become aware of it. And so something I hacked together a little bit was a proof of concept policy service implementation that would actually, when an artifact is deployed into wasmCloud, it would actually check that that artifact has been signed before it allows it for that component to be started. So let me export this URL again, because I don't want to use an already signed artifact. I will go ahead and wash push. Let's just wash push this thing again. So build hello world. So let's just do, yeah, that's fine. Okay, so in the background, I have the proof of concept service is a Go service. I won't go into details why that's important, other than the fact that the Sigstore ecosystem is in Go, so this was the easiest, fastest way to integrate it with it. And that's all you need to know about it. There is also great library support on Rust side, actually, so this could conceivably be written in Rust as well. I just started with Go because that was where they had better examples in terms of how to integrate with it. Now, I have locally a Kubernetes cluster running that's just has a single instance of wasmCloud deployed with a Nats cluster and whatever. So what I'm going to do is I'm going to port forward to the I will port forward to the Nats service running inside of that cluster to just allow my locally running policy controller or policy service, sorry, to actually be able to talk to or interact with the Nats in the cluster. So that's what's going on here. So now I've got this policy service connecting to the Nats that's running in the cluster. And what we're going to do now is demonstrate a deployment of this. So if I go in here and replace the local file version, and I guess I should also have something that get all let's just have logs streaming in from the wasmCloud host pod. So we'll see when this when the workload gets pushed into the or is being started in the cluster, we should see some entries in the logs for the wasmCloud host saying like, hey, I need to check the policy service. It's being configured to basically talk to the policy service when it gets things that it when it needs to deploy things in the cluster. So in this case, let's do wash app deploy. It is wash app deploy, right? I guess I don't have anything configured locally to do. Okay, let's see here. Oh, is it not listening on the default? It should be on default. X default. Oh, cannot put manifest version already exists. Okay, so let's see here. This is praying to the demo gods. It says it's deployed. It did not show up here. That's weird. Did I not? This might be one of those demo effects is not actually being picked up.
Jonas, did you? I swear I saw you run the policy service before you port forwarded. Is like a wasmCloud stack running locally on your machine by chance?
Oh, you know what? You might be right. Aux grab wasmCloud. I probably do have. So let's just do wash down, just in case. Yeah, I think you're right. That might be what it is. Let me just reset that real quick. So port forward, and let's go run. You're right. I didn't think about that. So I probably, maybe I deployed this on the local one. You're right. I keep forgetting about that. List. Yes, you're absolutely right. That's what it was. Okay, let's do that again. Sorry. Good call. Thank you. Okay. So there we go. Okay, that's what it was. So now what we're seeing here is a lot of text. Sorry. So the important thing is actually this line here, which says policy denied request to scale component. Could not find an associated SIG-store attestation. And so the could not find an associated SIG-store attestation is actually just the text that I'm sending back from the denied message that I'm sending back as part of the policy decision from the policy controller that I wrote. So this is exactly the behavior we want. Basically, we told it, hey, you can't deploy this because it's not signed by SIG-store. Now, let's go ahead and actually fix that by going through the cosign sign operation again. So if I echo the OCI URL, I will take this part, cosign sign that, and where did I push? The digest is here. So I will just go ahead and sign it. I think that's the right one, maybe, hopefully. Okay, I think that is. So let's go ahead and sign it. The same process that I did before. Obviously, you would, in production setting, you would actually do this inside of a CI pipeline instead of as part of your local workflow, but it is possible to do it locally as well. Now, what should happen the next time it attempts to deploy this, and actually, I guess I could speed it up by doing wash app delete HTTP. What is the name of this app actually? HTTP hello world? No, that's not the name of it. Rust. Okay, so what I'm going to try to do is just delete this app to speed it up a little bit, because WADAM will try it every 30 seconds when you deploy it through WADAM, but rather than waiting for the 30 seconds, we could just redeploy. Okay, so now instead what we're seeing is this output. Oh, that's the provider starting, sorry. Where is, it should be getting the signature here. Hopefully that wasn't it? No, it still thinks that it didn't find an associated. Okay, so I might have screwed something up when I did the signing. It's possible. But the general idea here is that this should now, from this process of signing the artifact, this should actually be saying like, no, it's actually good to go, and it should actually be deploying the artifact instead of denying it, which it is currently denying, but proof of concept, so bear with me. Go ahead, Brooks.
Yeah. Just wanted to say that you didn't actually do anything wrong. So the policy service is internally caching the response that you have, or the host is caching the response that it had from the policy service. So for that same, OCI tag, we are internally taking, even though they're technically mutable, we're internally saying, OCI URL should not be mutable. So there we're not even reaching out to the policy service there. We're denying it for the same messages before. We do have a mechanism for this. There's a policy changes topic where you can invalidate a decision and all of that. But just to really say that like there's a caching mechanism built in, but everything should have worked here otherwise.
Okay, good to know. Yeah, I worked in a demo when I did it locally before, but I might have done the signing before I ran the policy service. So I guess if I were to go through this again with a new build and sign it before I try to deploy it, it would work. Actually, I guess I didn't actually, what I didn't do, I don't know, maybe I didn't sign it here. I changed it here. It doesn't matter. The point is, it should work. And once we actually publish something into the wasmCloud repository, it will work. Dan might actually have a version that he can show this actually working. So rather than me, I'd love to take more questions, but maybe we save those to the end once Dan has had a chance to walk through his demo, because I think they're kind of related enough to topics where it makes sense for us to address them together as a whole, just in there to make sure that we stay on time.
Sure. Let me take over and share real quick. Try and run through this relatively quickly. Where is the right? Here we go. Thing. So I believe this is the right screen. Yes. Everybody see? Yeah, there we go. Cool. So there's another side to all this SigSource stuff, which is actually build attestations. So last week, the story behind this basically, like, I think it was last Monday, we noticed that GitHub had introduced like, oh, hey, they have artifact attestations now in public beta. And we were already kind of talking about looking at some SigSource stuff. So kind of read through this and was like, wait, I bet we could probably do this with wasmCloud pretty effortlessly, right? They have released a GitHub action, you can just kind of plug into your pipelines, which is to attest build provenance. Now, key point, there's a difference between signing, which is what Jonas just showed you, which is basically I have an artifact and I am asserting that this artifact is the artifact that it is, right? It's basically saying if you download this artifact, you can trust that that artifact is what it represents itself to be. This is a different side of kind of that signing process, which is actually you can trust that this pipeline was in fact what built this artifact, right? It's a different level, and that's why it's attestations versus signing. It's a subtlety, but it's a key point. But anyway, so in a repo that we happen to throw together that's open source, I actually went ahead and just added this whole process to the end of the repo, or rather the end of the CI pipeline that builds this. So adding this with wash is actually pretty straightforward. You basically just push all of your the versioned tags, right, that you want. And then at the last step, you hold the digest. Now that we have those wash changes, you don't actually need this other tool that I'm using, but you save that long form of the digest. And that's actually what you end up passing to this artifact attestation action, right? And then it basically does the same thing that Jonah showed you, where it actually stores that in transparency log. And so what this looks like, which is pretty nice in the GitHub UI, is once that runs, it shows you that an attestation was created, right? And this is all sort of added just in line once the build completes. You get this kind of nasty looking JSON actually, which basically tells you that this was the digest, this is the commit, right? You're asserting that this is build provenance using this is all spec. This is the workflow, right? The GitHub tools will actually allow you to pull this bundle and verify it locally. And this is the mess of stuff that it produces. This is actually like, it's called an in toto attestation. There's like a million new things that I had to learn, like what any of these things are. There's a whole security ecosystem, which are all just like big blobs of JSON signed and produced in different ways. Like there's a whole industry for this. It's amazing. But anyway, this is what effectively is the mass of stuff that we are attesting to. And like Jonah showed you, because we're using the stuff that's built into GitHub, this all goes against the public transparency log. So this was the SHA, this is showing you that like this is what it was built. The difference between what he showed you and I'm showing you, or one of them, is like the name of the certificate is actually the pipeline that and the tag that originated this stuff, because that's what we're effectively proving, right? And so all this is actually on this open source repo. It's part of Cosmonic because we're looking to figure out how we take this and put it into like an open source wasmCloud project. This uses Fly, which is why it's not part of wasmCloud. Like we had a whole debate about it. But anyway, it's open source. You can look at it. But I'm going to show you the actual, switch to my terminal real quick. And I'll show you the same thing that Jonas was showing you in terms of enforcing this using a policy service. Now, I have a slightly different version of actually the same code that he wrote that instead of verifying a signature is actually verifying that build attestation, but it's the same idea. So I'm going to go ahead and I'm going to just start a component that it does not have a build attestation associated with it. So it's going to kind of hang, right? And the reason is because, again, it's got a policy denied request. And specifically, our error here is that it failed to verify the attestation. That's great. That's what we want our policy service to do. Now, to show you that it actually does work, I'm going to actually start this is actually the artifact that pipeline built just with the short SHA. I'm just going to call it signed. I'm going to let it do its thing. No manifest found. What? Oh no, demo gods hate me too. I literally just did this. Oh, it actually worked. I wonder if it's because I also might cached the policy request. I definitely ran through this earlier and restarted the pod specifically to get rid of that. That's fun. Okay. So, oh no, there it is. I think I just waited too long. Or rather, it got confused. Anyway, this is what you're supposed to see, right? So it did actually end up working. I think I just got distracted by whatever that was. But anyway, so this policy service outputs basically all the stuff that it found for polling this attestation. I'm not going to tell you how that all works because like we'll be here for the next half hour as I walk through every step of the verification process. It took a lot of reverse engineering from the SigStore open source code and the GitHub tool to figure out exactly how to glue the stuff together. But it does all work, right? And it has a little bit more detail here about sort of what this was. But effectively, the reason we know this was verified is because we get these verified blocks, the verified identity, verified timestamp. Like we got a good attestation here, so the policy service let it through. So yeah, I mean, all that stuff is really just to illustrate that there's a whole world of security tools that I think we're kind of starting to explore as a project. And if you care about this stuff, right, the policy service hooks that we have in the wasmCloud host are really, really nice for being able to, like, they're as flexible as you want them to be. So you can add all this stuff, today, basically walking through everything we just walked through, right, to deploy SigStore signed artifacts and build attestations into your pipelines now, right? And all this works with WebAssembly because we're able to use all of the open source tools that have been figured out for doing all the stuff with OCI artifacts. So I think it's pretty cool. I don't know how much we'll end up, like, I think we have some vague ideas about maybe adding some of this stuff to wash build, give it some flags, have it just happen automatically. If you're running your own versions of some of these backend services as part of SigStore, namely Fulcio and Recore, right? Maybe being able to plug into some of that stuff. I think it depends on A, what the community wants, B, what we think the future of some of the security tooling ends up looking like. But I mean, it's pretty neat. Two of us were able to throw this together in like a couple of evenings, basically. Like it was difficult, but it wasn't impossible, right? Whereas a year or two ago, right, the stuff was cutting edge. Like you had to be part of the project to even understand anything about it. So things are getting a lot better. Anyway, questions. I need to catch up on chat.
One thing I would add just to that, everything you said, is what's also nice is right now we're checking to see whether or not these things exist, but you could also add on to this like an OPA, which is something that Brooks had already done previously, and you could use these as sources of metadata as part of your policy decisions. So you could basically delegate it to a custom Rego policy that you could write using these as another data source, rather than making the decision, you could delegate that decision to an OPA that allow end users to write the policies or program the policy controller in a much easier way than having to write like hard code all these rules into the policy controller that you run. But through exposing them as policy data sources, you could be a lot more flexible in terms of updating things. So that would be pretty cool.
This is really cool. I jumped the queue maybe a little bit. I know we're at the end of time, so I won't. I'll ask a quick question, and then I want to respect everyone's time. So this is really amazing to see all of this work just on top of the existing, like to reiterate, on top of the existing build process that we have for wasmCloud, the existing policy service. Like no changes actually went into core wasmCloud to make this happen. That's really cool. And with the example that you're talking about, Jonas, where we could use like a rego policy with OPA, you could probably, if you already had a policy that was validating something from Wrecker, you could probably just reuse that out of the box with this, right? Like, I mean, it's the same concept. I mean, I'm sure the answer is it depends, but in general, you could probably just straight up reuse the same policy. Question phrased as a statement.
Answer phrased as an answer. Yes, I think there are some examples of like Rego policies for some of this stuff, and I think there may even be some gen reactions. There may actually be even some libraries that the project produces. I'm not sure because I haven't spent enough time with it, but yeah, the verification process that the policy service implementations that we both demoed should be something that OPA can handle, particularly because like Rego policies understand JSON natively, so you should be able to pick apart, even if like various portions of the attestation, you could say, hey, this wasn't produced by a pipeline that's one of ours, even if it's signed. Or hey, this isn't coming from a source that we have authorized, right? The SIG service actually has a like a policy admission controller for Kubernetes. Effectively, all that logic could be brought into either a custom policy service implementation or into like one that is just a generic like OPA implementation, and you can just layer in your policies. So sky's kind of the limit, just a matter of like learning what's out there and seeing what makes sense.
Yeah, Colin.
Is this so? Those were components, right? So providers, since there isn't really a container necessarily a container around. Oh, do we have it for providers?
Well,
too?
so
Okay.
if you push it into an OCI registry, this whole process still works, right?
Okay, I didn't know we could do providers for OCI. I didn't pay attention probably a few weeks ago.
Yeah, I mean, if you do like a wash push on a provider, right, and you point it in an OCI registry, same exact idea.
Right.
Yeah, and actually to that end, something that I'm really interested in exploring is turning the current PAR-GZ format that we have for providers into an actual OCI format that's native, so that the OCI, so the wasmCloud host only needs to download the version of the provider that's applicable to its architecture instead of all of them. Where there might be use cases where this could save you a lot of bandwidth potentially, so it'd be a nice improvement to have. So it's actually quite trivial to do. It's just a matter of like basically undoing the work we have today, and then, or not undoing it by adding an additional option for it. So that would then make it so that it's even more obvious that these are OCI things, and thus the native OCI things just apply. So yeah, something I want to do, and I have a pretty good idea, clear idea of what to do and how to go about it. It's just finding the time.
Yeah, that's awesome. I did send it in the Zoom chat, but just in case it doesn't propagate everywhere, that is on our Q2 roadmap. So that's an issue that we have open and we're looking at. So sooner rather than later is all I really want to say there. All right, folks. Well, we are over time, so I want to make sure everybody can get back to their day. I'm sure that this is going to spawn a lot of questions. The only thing I can ask for is that I would love to see the action that you showed, Dan, and the policy service that you showed, Jonas. Like seeing that code, I think would be really cool. So whenever we can share, I think that'd be great. And otherwise, all of us are available in the wasmCloud Slack. So if you have follow-up questions that we didn't get to today, just come hit us up in Slack, slack.wasmcloud.com. Nice. That'll be great. Under example security, that'll be really sweet to see. All right, everyone. Awesome community meeting, awesome discussion and demos. Thank you so much for coming this week, and we'll see you next Wednesday. Have a good rest of your day, y'all.